Quasar E-Motorsports.
What's up, guys? This is Quasar, and today we're going to start the kit for the KTM and Gas 65. So I've already got some things placed in there just to get a general idea of what we're going to do here. That's the QS 120 gear reduction motor, so we don't have to run a giant rear sprocket. We have ENC battery there. We're going to be running an ENC TrueMoto controller, the Noisy Cricket. So it's going to be a full ENC powertrain, and it's going to be a hot swap kit, just like the 150R over there. The goal with this kit is to basically make a bike that can replace the Gas or Husky E5 or the KTM E5, which is underpowered, has a tiny battery, you know, so when kids grow out of that bike, or if they want to move to something similar like this, then they can get a lot more power and a lot more run time with the hot swappable battery. Again, we're shooting for 15 to 30 seconds on the swap, so that should work out quite nicely. So with this kit, there's a couple things that will need to be done, and there's not really a way to get around it. We are going to have to remove these lower motor mounts. You can do that with a grinder or a hacksaw if you must. There is a mount that goes up here for the CDI that'll have to be taken off, and a small tab right here on this side that will have to be removed to make room for the battery box. I'm going to try and make it fit to where we don't have to shave the tank, but I'm pretty sure we're going to have to shave the tank. So if we put this tank up here, we're probably going to have to shave the corner of this tank off just a bit. Just take the whole bottom off right there, about a ½ inch. It's not going to change the look. I think if we follow this line right there, it'll look real natural, but it'll leave us enough space to slide that battery in and out. And the side that it's going to open, I probably want to do it on the sprocket side because all the wiring is on the other side. We're probably going to have to shave this plastic just where you see the plastic, not where the decal goes. So right at that bend right there, so it won't mess with the look. And all the plastics will still fit on there, or the decals will fit on the plastics as normal without having to cut them. So if we remove this little bit here, those mounts, then we can run the 120 gear reduction with the ENC powertrain in this. So that's going to be pretty fantastic. So right now we're working on the mount for the motor. I'm going to do this lower mount, just focus on getting the motor mounted, with keeping in mind that I want to do the battery box up top. So I'm going to leave some extra space to do that battery box. And I think that I'm going to do like a frame style design. So you have one big plate that goes across and the battery slides in through there, and then there'll be flat spots inside. But yeah, so I'm focusing on this. We've kind of got this figured out for the most part in cardboard. I'm gonna go ahead and throw it in the frame and mark where the bolt holes are and see if we can't get a pattern to go off of to start with. So as you can see here, I've made a wood mount as a mock-up to try to get that mount figured out. This is a difficult motor to mount in pretty much any bike because the mounts extend all the way out this way. And if we go to this side of the bike, you'll notice there's nothing out there. Yeah, so it's going to be very difficult to mount. You don't want to just mount this on one side of the plate. It needs to be mounted on both sides. Primarily on one side with at least one anchor point on the other side. And that's if you're using fairly thick material. I'm using 3/16. I may end up, if I'm doing a single mount on that side with an anchor point on this side, just here, and not using anything here, I'll probably make that plate 1/4 inch because it's going to be stronger, and then I'll anchor this over here to this mount using a spacer and another bolt. And the battery box is going to come up in here, so I'm probably going to just do like a trace type frame that mounts up to these radiator bolts up here and then back down here. And if I do that, then it can be just a trace style frame, like I said, and I can push the battery in and the motor can mount to that as well. So on this build, we're going to have to trim the tank. The 150R we did not have to, but you can see that natural line that they have in that tank. And what you're going to do is you're going to score it with your razor blade, and then you'll go deeper and deeper until you get through it. If you want to be safe, just do a little bit less than what you think, like I did there, and then you can clean that up later. Just make sure that it's flush on both sides, and then we're going to do the other side on the same line. So just a couple quick tips on trimming a tank. I've done lots and lots of tanks. They're actually fairly easy. Score it before you start cutting deep. If you score a line, your blade will follow through with it. Once you get about 2 millimeters in with the knife after you score it. You can usually just run it full depth and come along. The biggest one though is don't go too deep. Give yourself some room to play. If you go too deep, then or too, past your lines, you can't fix that. You can always shave it off. It's real easy. And honestly, these tanks are the plastic has high oil content, so they're actually fairly soft. They're pretty easy to trim. And if you do it in a connect the dot style, it's much easier to keep things straight. And then you just want to come back and look at it this way and make sure everything's relatively flat and even. You won't even be able to tell this when it's on the bike. It'll just have a hole in the bottom. But yeah, so like I said, a little less than you think. Connect the dots and score it first, and you should be doing just fine. It's fairly easy. You can do it. Alright, so I've got a rough form for what we're going to do here. I'm going to mock it up in wood next. We're going to do 2 of them in wood. They're going to mirror each other. I'm going to put one on the other side. I'm going to find out if that battery is going to slide in nice and easy. What I'm going to end up doing is probably putting some spacers on here and then doing like an end cap, like carbon fiber or something cool like that. And then there'll be one of these on the other side as well, and then they'll be met with a piece of flat aluminum on all the sides. So it basically is like a box that you slide into that's extended out on the end with a cap. And then I'm going to figure out the latching side over there. But for this build, with the way that this is all designed and the way the frame is, the best thing I could do is basically build like a rib cage to slide the battery in. There's not enough room to do like an enclosed box, kind of like the other one. It's similar like a rib cage on the 150R. But this is definitely more skeletonized. And so I'm going to finish that up, get that into wood, and then we're going to figure out what we're going to do for the ends. All this will be skeletonized and look awesome. But yeah, so that's what I got so far. So I've made the holder out of wood. Now you can kind of really see what I got going on here. The motor mount's down here, and then the battery's going to slide in between these 2 channels, and I'm going to put braces in between these so it can slide in nice and smooth. And I'm going to have to figure out how I'm going to attach the battery in there and lock it in. But this idea is the best I could come up with for this type of frame. There are no other mounting points for the motor, unlike the 150R where we were able to use a plate and attach everything down there. I could do that with this setup, but I think it'd be overly complicated and harder to mount. We'd have to come off that swing arm bolt, which we're already doing. So I figured this would look really cool and it would provide a better mounting situation. The idea when you're doing this kind of stuff is to upgrade and get better and try new things and learn more and more so you can really achieve your ultimate greatness in the end. But I think that's going to look really cool, especially when it's skeletonized and it's out of billet, machined aluminum. So yeah, it's not going to be billet, but it'll be machined aluminum. I think that's going to look really good. We can do like a carbon fiber end cap here for the battery. It's going to look really cool, and then I'm going to figure out the latching part on the other side, if I'm going to do latching or clamping or whatever. I'm not really sure just yet. We're still prototyping, but everything looks really nice. It fits in there good. Let's see. I just cut those out on a scroll saw, so that worked out nice. I'm probably going to prototype most of this in wood. That way I'm not wasting material. It gets pretty expensive. So yeah, next I'm going to finalize the motor mount and tie it into the battery tray system to find the best way to do that. So here's what it looks like with the battery installed. Again, I totally like this design. These are going to be braced, of course, here, and on the corners on the inside. But overall, it's going to be pretty sweet. All right, so we're on the computer now. We're in Fusion. I did that picture trick. You take a picture of a part with a ruler in it, and you can scale it to the ruler size, and it's pretty much like 99% the right size. I'm going to make this out of wood on the CNC just to make sure that it's perfect and that I don't have to move anything, and if I do, I can do that before I do it in aluminum. But we've got everything here, so here's the picture in the background. If we turn this down, you can see the actual sketch itself. And that's what the motor mount's going to look like. We've got a 12mm hole right here for the axle. We've got 10mm holes for the motor, and then we have our 8mm hole for the front motor mount. And this is the exact shape of that QS120. It fits really nice when I did it with the wood, and I moved that over to a composite epoxy board, and now it's in the computer. So we're gonna go ahead and make a toolpath for this, and we're gonna CNC this out of wood. All right, so we've got the CNC set up. We got the path programmed in. We're gonna go ahead and cut this out and see how it fits.
Do you feel alive?
All right, so that's looking really good. Let's find out if it fits. All right, so this is why we do this out of wood. Everything looks pretty great. This needs to be moved over a tad. This hole is perfect. Everything looks good over here. The gap around here looks fantastic. However, this hole needs to be moved to the right. I mean, maybe 1 millimeter. So we're gonna go ahead and do that in CAD, and then we're gonna cut this out of aluminum. All right, guys, the motor's mounted up, looks super flossy, and everything is fitting perfect. All right, guys, so the next order of business is to do the battery holder, which is going to be skeletonized. So I'm going to have to draw that up in Fusion 360, make some tool paths, and we're going to cut it out. All right, guys, I've got the battery side panel done. It looks freaking awesome, I think. We're going to go ahead and cut this out of wood. We're not going to do any of the interstitial spaces here because there's no point in the extra time. Just going to make sure the holes line up, and if they do, we're going to go straight into aluminum. If they don't, we're going to move things around just a tiny bit, and then we will cut it out of aluminum and mount it to the bike. And that looks good. So it's time for a tool change. We're going to change to the 4mm drill bit. Get some more holes drilled, and then we're going to chamfer, or we're going to face it, and then we're going to chamfer it, and we'll see what it looks like when it's finished. Just like that, we push cycle start again. It'll come over to home. or near the tool changer, it'll tell you what tool to put in. I'm gonna put that tool in. You have to program all this, by the way. Put the tool in, and then it will touch off on that again to get the exact height of the tool, and we will be facing. So I'm gonna clean this up first, and we're gonna get right back to it. All right, we squirted a little bit of WD-40 on there to give it some lubrication, and all we do from here is push play. Cycle start. It's gonna touch off the tool, make sure that we've got the right height, and we will be facing. All right, there's still some oil on there. I just blew everything off, but as usual, the Daytron never ceases to amaze. So, fantastic finish. We're gonna go ahead and move on to the chamfer now. Stay tuned. All right, so we've got the 45-degree chamfer tool loaded, and we're ready to go ahead and chamfer all the edges here. I've got two separate chamfers set. We're doing a 0.75 millimeter for all the contours, and on the bolt holes we're doing a 0.5 millimeter or half millimeter chamfer. I've also got a tip offset of 2 millimeters on both. That way the work is not on the very tip of the tool, which will degrade that really quick, and you just don't get as good of a chamfer. So yeah, those are the offsets, and hopefully that helps for you guys out there that watching this for machining. Chamfering is not very hard once you figure out how to do it, but learning it, I mean, you're gonna make some mistakes. So, okay. All right, ready for the chamfer. Alright guys, here we are. In my opinion, that turned out pretty damn good. I'm not a professional. You guys are learning with me as I learn if you're watching the channel, so I'm super happy with the results. I think it looks fantastic. It makes me very happy to be able to do something like this and pull it from your brain and turn it into something real. Anyhow, if there's anybody out there who has any tips or pointers on anything I can do better than I'm doing, feel free to comment. I'm an open book and I love to learn. The chamfer looks good. The finish looks good to me. Everything looks really good. So why don't we take this over and test fit it on the bike? Holy shit, that looks good. Yep, I'm pretty happy with that. I think it looks great. When we get the other side on there, we get those cross braces in there. I think this thing is gonna look so cool. I can't wait to see what's gonna happen in a year. The kits that I'm gonna be doing are gonna be just out of this world. When you have the tools and a little bit of creativity, the sky's the limit. Well, right now the dirt's the limit, but who knows where we're gonna be in a year. So I think that looks wicked. Everything is just super sweet. The motor fits perfect. I mean, everything just worked out really well. I sat and stared at this bike for a solid 8 hours designing how I was going to do this. You know, you might think it'd be fairly easy, but when you have to figure out how to tie everything in together when there's multiple things going on and find a way for it all to work together, to mount together, it's a bit complicated. I don't ever write anything down on paper. I don't draw anything on paper unless it's dimensions or something, if I'm doing some complex bolt holes or something like that, or measurements. Apart from that, really, I just do all this in my head. And, you know, I had no idea how I was going to do the skeletonization or the lattice. You know, I just kind of went with it. You know, anywhere there's a bolt hole, you know, there's a thicker material there. You know, a larger bolt hole, even thicker than up here. You know, I went with a 10 millimeter border and then just threw some triangles in there. Kept the struts in between the triangles going in the proper direction for strength. You know, kind of like up here, you're going to have forces pulling this way, so it's pulling from the bolt hole. You know, kind of like building a bridge in those video games or the games you play on your phone. You use the engineering to build a bridge with some structural integrity so it doesn't collapse. I mean, it's basically the same thing using triangles. You know, so it's not too hard. But yeah, if you want to do this stuff, play those games, build some bridges, you'll learn some stuff. Anyhow, I think this is coming out really good. I'm gonna do the other side now. I can't wait. So I've come to realize I've never shown you guys how I set up. This is the same thing you can find on YouTube, anywhere else. I mean, if you do your searching, but I use tape. I use either the orange frog tape or the green. I believe it's a 2060 Scotch. This is like incredibly strong tape. If I'm going with anything that's small that's going to get hot, I'll use this is a powder coat tape. This is a high temperature tape. You can probably use Kapton tape too. That probably works just fine. So what I do is I tape it up evenly. I make sure that nothing's overlapping. And I'll take my piece of aluminum and I'll trim the edges of this tape off like this. Like so. You don't want anything raised up on any of the edges, and you want this to be super clean, so, and that helps. And this HDPE, a lot of people say that tape won't stick to it. Well, they don't know what they're talking about. They're just talking out their ass because they've never tried it. This tape sticks to it really, really good. One of the tricks, though, is get yourself an aluminum dowel like this. I've just turned this on the lathe, and because it's a round, it has a tiny little contact surface. So if you scratch this across the top like this, just rub it across the top, you can actually see that it's pressed down the tape and it's actually a different color. You can see that line right there, and it presses it down really, really good. So you just run this across, press everything down, and that attaches the tape really nicely. We'll set this aside. We'll do the spoil board. Same thing. You can see it change color. I don't know if you can see it very well in the video, but it goes darker because my spoil board is black. So here's where it gets creative. Make sure this is really clean, because if you have anything raising the surface, you're not going to have a flat surface. This is where it gets really cool. Hold on. Let me get a razor blade. Alright, I got to trim the edge of this real quick. Once we trim the edge of this, I'll show you the cool part. This is where my part setting gets really easy. I come up with a little way to make this much easier than I've seen anyone else do it. You know, if you're making the same size parts frequently, then this way, this method I'm about to show you is really nice for that. So I have this aluminum stock here, and I've milled that on my big mill to be perfectly square. I have an end stop over here, and then there's a clamp right here. I slide this down to the end stop, and that'll butt up perfectly with my work surface right here. I'll take an Allen wrench. I'll throw a quarter turn on that. That's locked into place. Now what we do, take our super glue, and we just do some squiggly lines on each of these little surfaces right here, on each strip of tape, just like this. We'll do it on every single one, just a little bit, not too much. Now the trick when you go to stick this down is you got to be quick, because when you put the accelerator on the other side, it's going to want to cure like immediately. So you're going to want to be fast as you can. So when you're setting a big piece of work and you don't have like some kind of guide, it's super hard to get it perfect. Otherwise it's going to be crooked, and then I mean, I like to not waste aluminum, so my parts, my stock is like nearly the same size as my part. I have about 5 millimeters of extra space. So what we do is we'll grab our accelerant, and we don't want to spray this right here with this here, because any little mist will get on here and it'll be terrible. It'll cure it right away. So we're gonna go ahead and hit this up, just like this. All right, and we're gonna take our work right here. We're gonna set it on the edge against our block there. We're gonna line up the corner, and then we're gonna drop it down fast as we can and push. And what that's gonna do is gonna set it down. It's already set. That accelerant cures that super glue pretty much instantly. But since we have this to guide ourselves against, we can put some force against it, and when we slam that down, we get it compressed nicely, and then the level is, the height is even all throughout. So in some of my videos you might have seen that I didn't go far enough down, or I went too far. It's because I wasn't using this method, and some of the glue had cured before it could compress all the way and move out of the way. That's why we just do little squigglies, because when we push it down, those flatten out. And if you don't do it fast enough, then you'll have some parts that are higher than others, and obviously your facing will be off, your contours will be off, your depth will be off throughout the whole part. So if you do it the way I just showed you, it'll all happen pretty fast. It'll be the same every time. I can use the same exact work origin that I used in my last part, because it never moved. It's lined up on the edge here, it's perfectly square, and it's square to this, so, and it's flat. So you can't really beat that. It's a fast method that I came up with, using a couple of clamps and a piece of stock right there, so it works out really good. We are ready to cut the right side of the KTM battery tray. This one has a lot of extra features in it because it's the latch side, so I had to get that done. But yeah, we're gonna go ahead and start the cut and see how that turns out. And all we have to do is take this little Allen wrench, quarter turn, slide that back over here, and we're ready to work. All right, so this is for my boy Electro Brap. I bet he doesn't watch these videos. We'll find out if he comments or if he tells me, hey man, that's funny. There's a sticker. Electro & Co is where I get all my powertrains from. They have fantastic electric powertrains. Their new controllers are the business. They're the bomb. Anyhow, it's time to change the tool. I'm gonna go ahead and hit cycle start on the Masso. It's gonna bring us right over here to swap the tool out, and it's gonna tell us what tool to swap to. It's saying 4mm drill, so we're gonna go ahead and swap this out to a 4mm drill, and we are gonna drill. All right, that piece is finished. Looks like another successful build there. Looks fantastic. Super happy with the results on this machine. Let's go ahead and go fit it to the bike. All right, guys, that's the other side done. Looks just as good as the first side. Man, that is beautiful. Let's go ahead and do a little walk around. Oh yeah, that's sexy. Well, it's the end of the day for me. It's dark outside as usual when I'm done working. I'm gonna test fit the battery real quick and we're gonna call it a day. Oh yeah, that's what I'm talking about. So what we're gonna do is we've got these little holes here in the corners. We're gonna put some spacers there, some bolts through. We're gonna do a carbon fiber plate over the top of this. It's gonna be skeletonized, have my logo in it. It's gonna be pretty rad. And that's gonna hold this side in. And then as we come to the other side, we're gonna do two spacers here, and we're gonna have a hinge. and we're gonna have a carbon fiber plate that surrounds this. It'll go around the handle, and it'll go through here with the twist lock that comes over here to two spacers that have the other part of the hinge on it, and you're just gonna pop it open just like that. Slide the battery in, slide the battery out. Alright guys, so that wraps it up for this video. In the next video, we're going to go ahead and do the interstitial braces between the mounts. We're going to do the carbon fiber end caps and the latching system. So if you liked what you saw in this video, please like and subscribe to the channel. It helps me out a lot.